Hello students, I'm Mrs. Surii. So in today's class, we are going to do chemical reactions and equation part 2, types of chemical reaction. So we have seen different types of chemical reaction. So there are different type of chemical reaction. Let's do that. What are these type of chemical reaction? First, combination reaction, decomposition reaction, displacement reaction, double displacement reaction, oxidation and reduction reaction. In today's lecture, we are going to cover all these chemical reaction. Let's start with the combination reaction. As name suggests, two or more substances combine to form a single product. So A plus B is equal to AB. So you have seen that burning of anything, burning of suppose coal, release heat. So carbon when react with oxygen to give CO2, heat is released. The heat is released in which type of reaction? Exothermic. So this one product is formed. So this is CO2. This is combination reaction. Magnesium ribbon burnt in the presence of oxygen to form magnesium oxide along with the formation of heat. Let's do more example of combination reaction. Hydrogen combining with the oxygen to give water. Hydrogen gas combining with the chlorine gas to give hydrochloric acid or hydrogen chloride gas. So next is very important reaction. So what is this reaction? Let's do. So, you all have seen whitewashing at your places or at some place. So, what the person do? Whitewash के time, वो calcium oxide, other name of calcium oxide is quicklime. You must have seen that whitewash वाला person calcium oxide water में water डाल के, so they mix up. Okay, so the mix with the wooden stick most of the time. So you have seen that इसको outer part इस container को अगर touch करोगे, it is hot because it is a exothermic reaction. Calcium oxide, whose another name is quicklime, is going to react with water to form slaked-lime, calcium hydroxide. So this calcium hydroxide, okay, after whitewash, 2-3 दिनों के बाद, you are going to see that the walls are shining because of formation of calcium carbonate. This calcium hydroxide, which is slaked-lime, going to react with carbon dioxide from air and going to form calcium carbonate, which is also the formula of marble. Or this calcium carbonate is going to give shiny layer on the wall. Okay. So next reaction of combination is ammonia reacting with hydrochloric gas. So it is going to form ammonium chloride. Sulfur dioxide is going to react with what? Is going to react with sulfur dioxide to form sulfur trioxide. All these reactions are combination reaction. Let's do next reaction, decomposition, as it is just opposite of combination. A single substance is broken down into two or more substances. A single reactant break down into two or more product. It is endothermic. Now you have to tell me a few example of endothermic reaction from our daily life. Please comment in the comment section. Endothermic reaction from our daily life. Let's do decomposition reaction. That means heat is absorbed during this reaction. So decomposition reaction, these are basically of three types. If the decomposition is done with the help of heat, it is thermal decomposition, like heating of calcium carbonate we just have done. It is going to, give you calcium oxide, quicklime along with the carbon dioxide. Or decomposition can be done by electricity, electrolytic decomposition, By if decomposition is done by light, it is photolytic reaction. Let's do all these decomposition one by one, starting with the thermal decomposition. Thermal decomposition, what is this, see, if thermal decomposition, let's do example of thermal decomposition. Potassium chlorate, KClO3, it is decomposed into potassium chloride and along with the formation of oxygen, this is with the help of heat. Heat is absorbed, endothermic reaction. So one you have must have heard ferrous sulfate, which is actually green vitriol when they have this water of crystallization FeSO4, FeSO4 7H2O, this is hydrated salt. When it is heated, it is going to give you ferrous sulfate, FeSO4, which is anhydrous salt. Anhydrous, that what the salt which lose its water of crystallization. So ferrous sulfate broken down into ferric oxide and sulfur dioxide and sulfur trioxide in with the help of heat. This is thermal decomposition. Another a good example is lead nitrate. Lead nitrate, it is a colorless compound which is going to broken down, decomposed into lead monoxide, nitrogen dioxide, and oxygen. See, lead nitrate originally is a colorless substance. During after decomposition, it is going to change into lead monoxide, which is a yellow color substance. In part one, we have done that chemical reactions, they are going to show some characteristic feature, either change of color or liberation of heat, absorption of heat, or the evolution of gas. So they can show any of these characteristic features, sometime one or two characteristic features too. So these are thermal decomposition. Let's do now, very good example of, this electrical decomposition. Let's do when decomposition done with the help of electricity, with the help of electricity. This is broken down into water. When water split into hydrogen with the help of electricity, this is electrolytic decomposition into hydrogen and oxygen gas. So it is going to form two part of hydrogen, one part of this. So for this, there is a, operator setup in which two electrodes are there. One is anode, another one is cathode. In pure water, we have to add a few drops of dilute sulfuric acid. So, see, a pure water, will not conduct electricity. So, to conduct, it is a poor conductor of electricity. We have to add a few drops of acid. So, it acts as an electrolyte. It allows the solution to conduct electricity. So, this oxygen is liberated as oxygen is negatively charged on negative electrode, which is cathode, hydrogen is liberated. Yes, electrolytic decomposition or electrolysis, electrolysis of water. When water is decomposed into hydrogen and oxygen gas in 2:1 ratio. For this operator setup, we are going to take two electrode, anode positively charged, cathode negatively charged. They both are connected to a battery. Pure water is taken along with a few drops of dilute sulfuric acid. As you know, pure water is a poor conductor of electricity. So, few drops of sulfuric acid, what it is going to act? It act as an electrolyte. So, if act as an electrolyte, it allow the solution to conduct electricity. Once it is connected to the battery, it will conduct electricity as sulfuric acid act as an electrolyte. So oxygen, you are going to observe being negatively charged at the positive electrode, which is anode, and hydrogen is liberated at negative electrode cathode. By this way, we are, going to observe these. So oxygen is toward anode. So, and hydrogen at cathode, this is electrolysis of water. By this way, we can observe, two volume of hydrogen along with the one volume of oxygen. Yes, next is photochemical decomposition. Silver chloride and silver bromide, under the effect of sunlight, they will broken down, decomposed into silver and chlorine gas, silver and bromide, bromine gas. So what they are, this is used in the photography or black and white photography. So that is, there is a very important question, why AgCl and AgB are kept in the black bottles? To protect it from the sunlight. Otherwise, they will react with the light, sunlight to and decomposed into further substances. So is this clear? Yes. Next is next is displacement reaction, third type of reaction. A reaction where a more reactive element, replace the less reactive element from its solution. You have seen that iron, being more reactive, displaces copper from its solution to form iron sulfate and copper. So blue solution of this copper sulfate turned into the reddish brown because iron has displaced copper from its solution. For, we are going to observe plain blue ground. For all these, you must know which one are the more reactive, which one are the less reactive. So we have to refer a reactivity series in which potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, above hydrogen, these metals are most active and called reactive metal. Below hydrogen, copper, silver, gold, platinum, least reactive. So more reactive will displace less reactive from its solution. So metal at the top are highly reactive, downward are less reactive. So metal above hydrogen can displace hydrogen from its dilute acid too. So let's do more example of displacement reaction. So this is very important. First of all, we have to, deeply understand this reactivity series. More reactive metal displaces less reactive metal from its salt solution. Let's do these type of reaction. Let's write like copper sulfate reacting with the zinc. Zinc being more reactive than copper will displace, copper from its solution to form zinc sulfate along with the copper. Okay, so this will displace. Like magnesium being more reactive will displace copper from its solution. Yes or no? Yes. To form magnesium sulfate along with the copper. So now let's take iron, which is, more reactive, which we have already discussed at the start of this reaction, is going to form iron sulfate and the copper. So this is about displacement reaction. More reactive, more active metal will displace less reactive from its solution. This is very clear. So this is about displacement reaction. Yes. The fourth type of reaction, double displacement. There is an exchange of ion between reactant to form new compound. See, of during this type of, reaction, most of the time you are going to see insoluble solid, which are called precipitate. Like the sodium sulfate is going to react with barium chloride. There is an exchange of ion. So what it is going to form? Barium sulfate, yes, and along with the sodium chloride. So there is an exchange of ion. So let's do one more example of this. Silver nitrate, when it is going to react with sodium chloride, write down. Sodium chloride. So there is an exchange of ion, that is why AgCl and NaNO3. Sodium nitrate, so silver chloride, white PPT of silver chloride along with the formation of sodium nitrate. So there is a exchange, there is a clear, exchange of ions between the reactants. So an insoluble precipitate is formed. This is called double displacement reaction. Let's do one more example of double displacement. Lead nitrate, PbNO3. Yes, lead nitrate reacting with potassium iodide. What it is going to form? So PbI, I told you there is an exchange of ion. Lead iodide along with the formation of potassium nitrate. So this is, let's balance also, balance this equation. Now it is balanced. So there is an exchange of ion. So from this reaction, you are going to see there is an exchange of ion and an insoluble precipitate is formed. So this type of reaction is called double displacement reaction. Let's do the last part of the reaction, last type of reaction, redox reaction. Oxidation. So first of all, to understand these reactions, you must know what is oxidation. What is oxidation? So oxidation is gain of oxygen, loss of hydrogen. Reduction is opposite, loss of oxygen, gain of hydrogen. So when these reactions, RED redox, RED means reduction, OX oxidation occur simultaneously. These reactions are called redox reaction. Like copper, if we add oxygen and heat this, so it is going to form copper oxide. This is clear oxidation, just addition of oxygen, oxidation, addition of, in copper oxide, addition of hydrogen is also oxidation, or loss of, actually loss of hydrogen is oxidation, addition of hydrogen is reduction. Okay, so copper plus H2O, if hydrogen gas is passed, so this is called, so what is it called? If we add hydrogen, this is called, copper is formed. Let's do the both oxidation and reduction will occur in this reaction. So copper oxide, this is reduced as there is loss of oxygen. There is a, this is oxidation. So in this reaction, both oxidation and reduction occur simultaneously. That is why it is called redox reaction. So some other redox reaction like zinc oxide, adding carbon, and it is going to give you zinc plus carbon monoxide, MnO2 plus HCl, it is going to give you MnCl2 plus water plus Cl2. Okay, tell me which type, which is oxidation, which is reduction in this reaction. Yes. So one type is oxidation, one is reduction. Name the substance which undergo oxidation and which undergo reduction. This you can tell me in the comment section. Thank you for watching my class. Thank you so much.